Welcome to the deep dive. It's Sunday, March 8th, 2026, and I am absolutely thrilled you're joining us today.
Truly, it's great to have you here with us.
If you're anything like me, you've probably been, watching the streets, reading the headlines, and just feeling this low-level hum of transformation all around
Oh,
us.
totally. The shift is palpable.
Right, especially when it comes to the cars we drive.
Yeah.
So today, we're going on a very specific mission designed entirely for you.
We've been doing a lot of reading this week.
A mountain of reading. We've been buried under recent automotive industry reports, confidential pricing sheets, highly technical engineering specs.
And we're distilling all of that down.
Exactly. We're creating a comprehensive, engaging briefing document
Yeah.
just for you, synthesizing all this data into exactly what you need to know about the future of transportation.
Because, frankly, there is so much daily noise out there.
So much marketing jargon.
Right, the endless marketing spin. So we filtered that out to focus on the absolute core of what is happening right now in the automotive sector. We're looking at a stack of sources covering groundbreaking battery chemistry, the sudden democratization of the city car market.
Which is huge.
Huge, plus the strategic moves by the luxury heavy hitters and some bizarrely cool, sustainable materials that are fundamentally changing vehicle interiors.
Okay, let's unpack this. Because reading through these sources, I realized we aren't just looking at cars getting a little faster or sleeker.
No, not at all.
We are looking at a massive structural shift in how these machines interact with our daily lives. I mean, for the longest time, electric vehicles felt like they were in this extended beta testing phase.
A pioneer era.
Exactly, a pioneer era where you had to make serious compromises if you wanted to drive electric. But looking at these 2026 reports, it is officially the year the EV industry graduates.
The training wheels are well and truly off.
They really are. We're entering a highly advanced second and third generation era.
And setting the central theme for our discussion today, it's crucial to understand that the focus of automotive engineering has fundamentally shifted. For the last 10 years, the headline numbers were always about raw speed, right, or acceleration.
Yeah, how fast can we get this massive battery from 0 to 60?
Right. But those metrics have been solved. What this 2026 data shows us is an industry entirely focused on solving the historical, structural limitations that held back mainstream adoption.
The real pain points.
Exactly. Namely, the limitations of driving range, the sheer frustration of slow charging speeds, and most importantly, the massive barrier of affordability.
Which brings us to a topic I know you've been eager to tear into. I want to talk about the elephant in the room that has haunted early EV adopters for over a decade.
Range anxiety.
Range anxiety. You know the feeling.
Yeah.
If you're driving down the highway, you look at the dashboard, the battery percentage is dropping slightly faster than you
A
anticipated.
Titanic sets in.
Yes, suddenly you're doing complex mental math, like where is the next charger?
Is it even working?
Right. Is it broken? Is there a line of 4 cars waiting to use it? It was a massive psychological barrier. But according to the data in front of us, 2026 is the year we officially erase range anxiety from the dictionary.
It's gone.
So what exactly is shifting here?
What's fascinating here is that the shift is, well, we are moving from incremental improvements to exponential leaps.
Okay.
You mentioned the psychological burden. Early electric vehicles demanded that the driver change their behavior to suit the machine.
Yeah, you had to plan road trips meticulously around the car.
Exactly. But the shift we're seeing now, specifically with the commercialization of solid-state batteries, flips that dynamic entirely. The machine finally serves the driver's lifestyle, without caveat.
Solid-state batteries. I feel like I've been reading about these in tech blogs for 10 years.
Always 5 years away. Right.
Always. They were perpetually 5 years away. It was the holy grail of battery tech that just never seemed to actually arrive.
Until now.
Right. I'm looking at these reports and they show brands like Toyota and Dongfeng aren't just tinkering in a pristine laboratory anymore.
No, they are currently testing the first commercial applications of solid-state batteries on the road, right now.
And the numbers they're pulling from these tests are staggering to me. We're talking about the promise of over 1,000 kilometers of range on a single charge.
It's an incredible leap.
1,000 kilometers. You could theoretically drive from Paris to Berlin
Yeah.
and still have battery left to navigate to your hotel and go out to dinner.
Easily.
So why is this suddenly happening now, and what exactly makes a battery solid state?
Well, what's fascinating here is the foundational change in the chemistry itself.
Okay, break it down for me.
For the last 2 decades, our laptops, our phones, and our electric cars have relied on lithium-ion batteries that use a liquid electrolyte. Think of the liquid electrolyte as the fluid medium that allows lithium ions to swim back and forth between the positive and negative sides of the battery when you charge and discharge it.
Wait, so there is literal fluid sloshing around inside the battery cell.
Essentially, yes. And that liquid has fundamental flaws.
Like what?
Well, it's sensitive to extreme temperatures, it's highly flammable, and over time, as the battery cycles, tiny microscopic spikes called dendrites can form in the liquid.
Dendrites. That sounds bad.
It is. If those spikes grow long enough to pierce the separator between the positive and negative sides, the battery short circuits.
Oh, wow.
So to prevent that, engineers had to build massive heavy cooling systems and severely limit how densely they could pack the energy in.
I see.
But a solid-state battery replaces that volatile liquid with a solid conductive material, usually a specialized ceramic or a glass-like polymer.
So by making it solid, you basically remove the flammability risk and the need for all that heavy cooling apparatus.
Precisely. And because the solid material is so much more stable, you can massively increase the energy density.
You can just pack more power in.
Exactly. You pack a significantly higher amount of power into the exact same physical footprint. It's lighter, it's safer, and as you noted, it pushes the range past that magical 1,000-kilometer threshold.
That is just wild.
But the range is only half of the equation here.
Right, the charging speed.
Yes.
Yeah.
Because the battery architecture is so thermally stable, it can accept a charge at a rate that would have literally melted older liquid-based batteries.
Oh, wow.
Our sources indicate these commercial tests are achieving an 80% charge in less than 10 minutes.
Less than 10 minutes. That completely alters the entire rhythm of a road trip for you.
Completely.
You pull over to stretch your legs, maybe run inside to grab a bottle of water and use the restroom, and by the time you're walking back to the car, you have another 800 kilometers of range loaded up and ready to go.
It changes everything.
It makes the electric car not just a great vehicle for running errands around the city, but the ultimate grand tourer. But reading further down in this section, it's not just the solid-state magic happening. Even the traditional lithium-ion architecture is getting a massive upgrade in 2026.
That's right. The sources detail a massive industry-wide shift in high-voltage architectures.
Yeah, the reports talk about the migration to 800-volt and, in some high-end cases, 1,200-volt systems.
This is an engineering pivot that solves the throughput bottleneck.
I want to break this down because voltage can be a tricky concept to visualize. In the reports, they specifically highlight the new Mercedes electric C-Class and the Porsche Cayenne EV utilizing these 800-volt and 1,200-volt systems.
High-end models setting the standard.
Exactly. And the specification that jumps right off the page is the ultra-fast charging capability supporting up to 400 kilowatts.
That is a staggering amount of power.
To put 400 kilowatts into perspective for you, well, imagine you're at a cafe on the side of the highway. You walk up to the counter, you order a quick espresso.
My barista grinds the beans.
Right, pulls the shot. You drink it standing at the counter. Maybe you check a single email on your phone. In that exact window of time, maybe 3 or 4 minutes, this new high-voltage architecture has pulled down 400 to 500 kilometers of range.
It's incredible.
You are literally adding highway miles to your car at the speed of caffeine consumption. How does doubling the voltage make that espresso speed charge possible?
The best way to understand electricity in this context is to think of it like plumbing.
Okay, plumbing.
Voltage is the water pressure, and amperage is the size of the pipe.
Got it.
If you want to push more water or more energy into a battery very quickly, you have two options. You can either make the pipe much larger by increasing the amps, or you can increase the pressure by increasing the volts.
And if I recall from physics class, increasing the amps creates heat, right?
A tremendous amount of heat.
Right.
The standard for the vast majority of the first-generation EV fleet was 400 volts. It was a reliable standard, but it placed a hard ceiling on how fast you could push electricity into the vehicle.
Because of the heat.
Exactly. If you tried to push 400 kilowatts of power through a 400-volt system, you would need cables as thick as your arm, and they would still overheat and potentially melt.
Yikes.
But by stepping the system up to 800 volts or 1,200 volts, you double or triple the pressure.
Ah, I see.
This allows you to push massive amounts of energy through relatively thin, manageable cables without generating excessive heat.
So the car can basically swallow the energy as fast as the charging station can physically dispense it.
Precisely. And if we look beyond just the individual driver, this kind of charging speed entirely changes the infrastructure requirements of a city or a highway network.
How so?
Think about the logistics. If a car only needs to occupy a charging stall for the length of an espresso break, rather than sitting there for a full lunch hour, the throughput of a single charging station practically
Oh,
quadruples.
that makes total sense.
You suddenly eliminate the queues at rest stops during busy holiday travel weekends. You eliminate the friction of ownership.
The friction is just gone, which transitions us perfectly into the second major theme from our briefing
A
documents.
very exciting theme.
Yes, because 1,000-kilometer ranges and ultra-fast charging are incredible feats of engineering. But historically, whenever we talked about those kinds of specifications, we were talking about cars reserved for people spending six figures on a luxury sedan.
It was tech for the elite.
Exactly. But looking at the 2026 roadmap, that is no longer the case.
No. While the technological ceiling is being raised by the luxury brands, the most significant and culturally impactful revolution of 2026 is actually happening at the absolute foundation of the market.
A budget market.
The true paradigm shift we are documenting today is the democratization of the electric vehicle. The industry has fiercely locked onto a psychological and financial threshold.
The 20,000 to 25,000 euro battleground.
Exactly. This is where the future of global mobility is actually being decided.
It's the sweet spot. It's about making these cars accessible to everyone, not just early adopters with deep pockets or corporate fleet accounts. And the models rolling out to fight in this 20,000 to 25,000 euro trench are absolutely fascinating. They aren't just stripped-down penalty boxes.
Far from it.
They are highly engineered, incredibly clever machines. Let's start with the one that just made me smile the most reading through these design reports, the Fiat Grande Panda.
It is clearly positioned as the spiritual heir to the classic boxy Fiat Panda that mobilized millions across Europe in the 80s and 90s.
It really has that vibe.
It's a brilliant piece of industrial design, arriving with a highly aggressive price tag of roughly 23,900 euros, net of various government incentives.
Okay, so 23,900, and the spec sheet notes it gets about 320 kilometers of range from a 44 kilowatt-hour battery.
Correct.
Now, 44 kilowatt-hours might sound a bit small compared to the massive 100 kilowatt-hour packs we usually hear about in luxury SUVs. But for a light, aerodynamic city car, 320 kilometers is more than enough for a week of commuting.
More than enough for the average driver.
But I have to geek out for a second about what the reports call its superior feature.
Integrated cable.
Yes, because it solves a problem that every single EV owner knows intimately, but nobody seemed to be fixing: the charging cable.
The physical interface between the infrastructure and the vehicle has long been a pain point.
It is awful. Historically, if you pull up to a public AC charger on a city street, you have to pop the trunk. You have to dig into your groceries or your gym bag just to find this heavy, thick cable.
And if it was raining,
If it was raining earlier, the cable is wet and dirty. You rustle it out, plug one end into the station, the other into the car,
right,
and then you have to reverse the whole messy, annoying process when you're done, throwing a wet cable back into your clean trunk.
it always felt like a very analog, clunky user experience for a supposedly futuristic digital machine.
Exactly.
It was a clear holdover from an era where engineers were solely focused on making the powertrain function. UX user experience was an afterthought.
But looking at the design schematics for the Grand Panda, they've introduced an integrated charging cable hidden right under the front grille.
It's so clever.
It's a spiral cable, kind of like an old-school telephone cord or a heavy-duty vacuum cleaner cord. You just pop a little door on the grille, pull the cable out, and plug it directly into the charger right in front of the car.
Seamless.
When you're done, you give it a tug, and it retracts automatically back into the front of the car. No more dirty hands, no more digging through a messy trunk. It is such a remarkably simple, human-centric design choice. Why did it take until 2026 for an automaker to finally implement something so obvious?
Well, it highlights a maturation in engineering philosophy.
Adrian.
As I mentioned, the pioneer phase was about foundational survival, making the battery work, making the motors reliable. Now that the baseline technology is robust and commoditized, engineers finally have the breathing room to focus heavily on the daily user experience.
So you look at the minor friction points of daily life.
Exactly. And we see this exact same user-centric philosophy applied to a completely different problem in the next major contender in this price bracket, the Citroën EC3.
Ah, yes. The briefing document has dubbed the Comfort King.
It is a fitting title. The pricing strategy here is even more aggressive than the Fiat. It starts at 20,490 euros.
Wow.
And our sources note that with current European market promotions, it is frequently dropping well below the €19,000 mark.
That is extremely competitive.
It is. It offers the same 320-kilometer range as the Panda, utilizing similar battery chemistry, with an even cheaper 200-kilometer urban range version available for drivers who strictly stay within city limits.
So what's the hook?
The superior feature here isn't a clever cable mechanism, it is the fundamental ride quality.
You highlighted the Citroën Advanced Comfort suspensions heavily in your notes. What makes this so special for a budget car?
Because it's historically unprecedented at this price tier. Typically, a sub €20,000 subcompact car has a very stiff, highly utilitarian suspension,
Right, because the mandate for budget cars has always been to make them cheap to produce and durable.
which usually means simple mechanical springs and basic shock absorbers. The result is that you feel every single bump, crack, and pothole in the road.
A classic budget car rattle.
Precisely. But Citroën is utilizing what they call progressive hydraulic cushions in the EC3.
How does a progressive hydraulic cushion differ from a regular shock absorber?
In a traditional budget suspension, when the wheel hits a large bump and the spring compresses fully, it hits a mechanical bump stop.
Like a hard piece of rubber.
Yes, essentially a hard piece of rubber to prevent the metal components from crashing into each other. That abrupt stop sends a harsh jolt right up through the chassis and into the driver's spine.
We've all felt that.
What Citroën has done is replace that hard mechanical stop with a fluid chamber. As the suspension reaches the end of its travel, it pushes hydraulic fluid through increasingly smaller valves.
Okay.
This acts to gradually and smoothly decelerate the suspension's movement.
Which means when you hit one of those awful jagged city potholes or you're driving over ancient uneven cobblestones in a historic downtown area, the car actually absorbs and dissipates the energy instead of transmitting it to you. The reports literally describe the ride as feeling like you're sitting in a luxury flagship sedan. Bringing that level of engineered physical comfort to a car that costs less than €20,000 is an absolute game changer for someone who spends 2 hours a day grinding through heavy urban commuting traffic.
It redefines the baseline expectation of what cheap feels like. Citroën is effectively democratizing physical comfort.
And while they are doing that, the Volkswagen Group is attacking a different limitation of the compact car.
Yes, they are democratizing physical space.
Space. If we analyze the specifications for the Skoda Epic and the VW ID.2, we see a brilliant exploitation of EV architecture.
These two are dubbed the space pioneers in our briefing.
Right. The base price is firmly planted at that €25,000 mark, and they're pushing up to a highly respectable 400 kilometers range for the larger battery trims.
Very respectable numbers.
But the real magic trick here isn't the battery, it's the physical footprint of the vehicle. These cars are only 4 meters long. For context for you listening, 4 meters is roughly the exact size of a standard VW Polo or a Ford Fiesta.
They're small, highly maneuverable city cars designed to fit into tight parking spots.
But when you look at the interior dimensions in these reports, the volume inside is massive. How are they bending space like this?
This is the ultimate realization of what engineers call a dedicated EV architecture.
Okay, walk me through it.
Think about the packaging constraints of a traditional combustion engine car. You have a massive, heavy block of metal, the engine sitting up front.
Taking up half the hood.
Right. You have an exhaust pipe and a drive shaft running straight down the middle of the chassis, which creates that annoying hump in the floor of the back seat.
The worst seat in the car.
And you have a bulky, awkwardly shaped gas tank in the back. The mechanical components dictate the entire shape and volume of the interior passenger cabin.
The car is built around the engine, and the humans just fit wherever there's space left over.
Exactly. But the Skoda Epic and the VW ID.2 utilize a dedicated flat-floor EV platform, often referred to in the industry as a skateboard chassis.
Because it looks like a skateboard.
Yes. The batteries are laid out completely flat underneath the floorboards, and the electric motors are incredibly compact, often the size of a watermelon, sitting directly between the wheels.
So there's no exhaust tunnel, no gas tank, and no massive engine block.
None of it.
Which allows the designers to push the wheels out to the absolute furthest corners of the car and carve out interior space that shouldn't mathematically exist in a 4-meter vehicle.
It's an engineering marvel.
I was looking at the cargo specs, and the Skoda Epic specifically boasts an unheard of 490-liter trunk.
That is massive for a car that size.
490 liters. That is the kind of cargo capacity you usually only find in a midsize SUV. You could easily fit an entire family's luggage for a 2-week vacation, plus a stroller in the back of a car that you can parallel park in the tightest spot in Rome or Paris.
It completely shatters the old automotive rule that dictated you had to buy a massive, difficult-to-park SUV if you wanted meaningful cargo space.
It really does.
It represents a massive shift in utility. It makes the highly efficient compact car viable as the primary or even the only vehicle for a family again.
And rounding out this 20,000 and 25,000 euro battleground, we have to look at the strategy coming from Renault, because they are approaching this market from a purely emotional and aesthetic angle.
Paired with some very serious grid technology.
The retro chic movement.
Yeah.
Spent a lot of time looking at the photos of the Renault 5 E-Tech and the upcoming Twingo prototype.
Beautiful designs.
The R5 base model is pointing right at that 25,000 euro mark, while the Twingo prototype is aggressively aiming to hit the 20,000 euro floor.
Yeah.
And honestly, they're just gorgeous to look at.
They tap into nostalgia very effectively.
They take these iconic, beloved, almost nostalgic silhouettes from the 1970s and 1990s and inject them with cutting-edge tech. The R5 is being marketed with this premium chic, highly sporty driving dynamic.
But looking at the technical breakdown, the superior feature here goes far beyond just looking good and hitting the nostalgia button. These affordable hatchbacks are bringing V2G tech into the mainstream.
Vehicle-to-grid technology.
Yes. We will explore the massive macroeconomic implications of this in much greater depth shortly, as it's arguably one of the most vital developments of 2026.
I can't wait for that part.
But the key takeaway here is that Renault is packing highly complex bidirectional charging hardware, the ability to not just take electricity, but push it back out into a 25,000 euro retro hatchback.
That is huge.
It proves that advanced grid integration is no longer a niche luxury feature for early adopters. It is rapidly becoming the standard baseline for all mobility.
It's an incredible lineup. We've got charging cables magically hiding in front grills, hydraulic suspensions making cheap cars ride like limousines, magic space-expanding trunks on skateboard chassis, and retro-chic grid-powering hatchbacks, all fighting for your attention in the 20,000 euro range.
A very competitive year.
But here's where it gets really interesting. Because while the budget market is completely transforming how we handle the daily commute, the luxury and extreme performance sector is doing things that read like absolute science fiction.
They operate on a different plane.
I want to pivot from the budget daily drivers to the absolute heavy hitters, the dream machines of 2026.
The luxury sector serves a very specific purpose in the automotive ecosystem. It is where we see the absolute bleeding edge of material science, aerodynamic research, and software engineering deployed.
Testing grounds.
Exactly. Because engineers are unburdened by the strict constraints of a budget price point, it serves as the ultimate proving ground for technologies that will eventually trickle down to the rest of the market.
And the first titan on our heavy hitters list is BMW, with their entirely new architecture for the i3 and iX3 lines.
The new class platform.
The new class. Now, automakers love to throw around fancy German names for marketing purposes, but the data attached to this platform is what caught my eye.
The efficiency gains are remarkable.
The reports state this dedicated platform yields a staggering 25% better energy efficiency compared to their previous generation of electric vehicles. I know enough about engineering to know that a 25% leap in efficiency in a single generation is not just a minor tweak.
Not at all.
How on earth are they achieving that kind of massive gain?
A 25% leap in structural and drivetrain efficiency is indeed monumental. It's the difference between a competent EV and a generational leap forward.
Right.
When automakers first transitioned to electric, many of them simply took an existing gas-powered chassis and crammed batteries and motors into the empty spaces.
It was a compromise.
Exactly. The new class platform is a ground-up reimagining. They achieve that 25% figure by designing the entire vehicle ecosystem cohesively around the battery.
What does a cohesive design look like in practice?
It means every single component is optimized for electrical efficiency. They completely redesign the copper windings inside the electric motors to reduce magnetic loss.
Getting into the weeds there.
They integrated an entirely new, holistic thermal management system that uses waste heat from the motors to warm the battery in cold weather, minimizing energy drain.
Oh, that's smart.
Furthermore, the structural integration of the battery casing into the frame of the car itself increases rigidity while dropping hundreds of pounds of weight.
Losing weight is always good for efficiency.
Always. And finally, they achieved incredibly low aerodynamic drag coefficients. Every millimeter of the vehicle's surface is sculpted to slice through the air with minimal resistance.
So you combine the weight loss, the motor efficiency, and the aerodynamics.
And you squeeze out every possible meter of distance from a single kilowatt of energy, which is exactly how they're achieving ranges of up to 800 kilometers.
800 kilometers in a luxury SUV. That means you could drive from Munich down to Rome on a single charge, wrapped in soundproofed, leather-lined luxury.
A very compelling package.
It is. But BMW isn't the only giant making massive moves in this space. The reports also detailed the highly anticipated restyling of the vehicle that completely disrupted the industry.
The Tesla Model Y.
Yes, the world's best-selling car. This is internally referred to as the Juniper update. Now, Tesla has always been an interesting case because their hardware updates often take a backseat to their software. What is the focus of the Juniper update?
It's notoriously difficult for an automaker to update a global bestseller without alienating the consumer base that made it popular.
Don't mess with success.
Exactly. With the Juniper update, Tesla is focusing heavily on refining the unseen architecture while upgrading the interior materials to compete more aggressively with the German luxury brands.
Make it feel a bit more premium.
Right. They are integrating much denser battery packs, pushing the real-world range to a highly reliable 580 to 600 kilometers. But as you astutely noted, the true differentiator for Tesla has always been, and remains, their software.
The autonomous stuff.
Specifically, the massive improvements to their FSD, or Full Self-Driving suite.
Right. It feels like we've been hearing about cars driving themselves for years, and while highway autopilot is common now, city driving is a completely different beast.
A much more complex environment.
The briefing notes mention that the 2026 iteration leverages vastly more powerful onboard neural processing. Why does a car need a neural network just to drive down a street?
Because the complexity of unstructured urban environments is staggering for a computer to interpret.
Okay, give me an example.
Highway driving is relatively simple. The lines are painted clearly, traffic moves in one direction, and there are no pedestrians. But imagine driving through a busy intersection in a city like Naples or Mumbai.
Pure chaos.
You have pedestrians stepping off curbs, cyclists weaving through traffic, delivery trucks double parked, and temporary construction zones with confusing signage. A traditional computer program relying on hard-coded rules, if X happens, do Y, cannot handle that level of chaos.
There's simply too many variables to write a rule for every single one.
Exactly. That is why Tesla relies on neural processing. The car's computer mimics the architecture of a human brain. It doesn't rely on rules, it relies on experience.
It learns.
It ingests massive amounts of video data from millions of other Teslas on the road, learning to recognize patterns and predict human behavior. Wow.
The Juniper update includes a significant leap in raw processing power, allowing the car to analyze this chaotic visual data and make split-second steering and braking decisions with a level of fluidity and confidence that earlier, more hesitant versions lacked.
It's a massive step forward in autonomous capability.
It really is.
It's incredible to think about the car as primarily a data processing machine. It's less about the hardware of the wheels and more about the brain interpreting the world.
A supercomputer on wheels.
But if we want to step away from AI and talk about raw, visceral, tire-smoking hardware, we absolutely have to talk about the Alpine A390.
Ah, Alpine.
Alpine is bringing pure, unadulterated motorsport to the EV landscape. This car has a highly respectable 555-kilometer range, but honestly, looking at the specs, range is the least interesting thing about it.
It's built for performance.
It features a triple motor setup, 3 distinct high-powered electric motors. Why put 3 motors in a car?
To achieve true instantaneous torque vectoring. This is where electric vehicles fundamentally rewrite the laws of performance dynamics.
In a high-performance combustion engine car, you have a single engine up front or in the middle. That single engine sends its power through complex, heavy, and reactive mechanical differentials to distribute force to the wheels.
Right.
If a wheel starts to slip in a corner, mechanical gears have to react to limit the power. It takes time, even if it's just fractions of a second.
But with 3 individual motors, presumably 1 for the front axle, and 2 dedicated to the individual rear wheels.
Yes. And because there is no mechanical connection between the left and right rear wheels, a central computer can precisely dictate exactly how much torque is sent to each individual wheel, millisecond by millisecond.
That sounds intense.
Think about taking a sharp left-hand corner on a racetrack. The Alpine A390's computer can instantly overdrive the outside right rear wheel, pushing it harder, while simultaneously applying slight regenerative braking to the inside left front wheel.
So it's artificially pivoting the car around the apex of the corner, like a tank turning its treads at different speeds but happening at 150 kilometers an hour.
Exactly. It forces the nose of the car precisely where you point the steering wheel, completely eliminating understeer.
It just corners like it's on rails.
It provides a level of agility, rotation, and track-level responsiveness that is physically impossible for a traditional mechanical drivetrain to replicate, no matter how perfectly engineered.
Yeah.
It makes the car feel incredibly light and infinitely controllable.
It literally rewrites the laws of physics when you throw it into a corner.
Yeah.
I love it.
Yeah.
But speaking of rewriting rules and upending traditions,
The big one.
the final heavy hitter in our briefing document is one that automotive purists have been agonizing over and debating for years: the Ferrari Electric.
The prancing horse.
The prancing horse has officially entered the EV chat. Now, a lot of people thought Ferrari would hold out on electric power forever, clinging to their V12 engines, but they haven't.
No, they haven't. And true to their lineage, they have entered the space with overwhelming force. The physical specifications are exactly what you would expect from the engineers in Maranello.
Which are insane.
Well over 1,000 horsepower, a range of 500-plus kilometers, and an aerodynamic profile that belongs in a wind tunnel.
1,000 horsepower. That kind of power will pin you to the seat so hard it hurts. But here is the detail that absolutely fascinated me, and I noticed you zeroed in on this in your analysis as well.
The sound issue.
Yes. The biggest, loudest criticism of electric sports cars, especially from traditional enthusiasts, is that they are soulless. Yes, they are fast, they accelerate like a roller coaster, but they are silent.
They lack the mechanical drama.
Exactly. They lack the vibration, the rising crescendo of a gas engine approaching 9,000 RPM. Ferrari knows this is their heritage. So the reports reveal that Ferrari has designed a highly complex custom sound for this electric hypercar.
It's a very controversial move.
Now, I have to ask, is this just a speaker playing a fake recording of an old V12?
Yeah.
Are we just putting playing cards in the spokes of a very expensive bicycle?
It is a vital question, and it speaks to a profound debate about the psychology of driving. To answer your question directly, no, it is not a simple recording. The patent suggests it is far more sophisticated.
Okay.
But it forces us to ask, why do drivers need auditory feedback in a vehicle with extreme performance?
That's a good question.
We associate loud noise with power because, for over a century of automotive history, generating power required thousands of controlled explosions per minute inside metal cylinders.
Literal explosions.
The noise was an unavoidable, chaotic byproduct of the violence of combustion. Over time, we romanticized that byproduct. We tuned it to sound musical. But an electric motor is inherently smooth, highly efficient, and nearly silent.
Which is great for a luxury sedan, but terrible for a supercar. Human beings are deeply sensory creatures. When you apply 1,000 horsepower to the tarmac and launch a car from 0 to 100 in under 2 seconds, your brain needs an auditory cue to contextualize the extreme G-forces your body is suddenly experiencing.
It's about sensory grounding. Without the corresponding sound, your brain actually gets confused.
I can imagine. Your inner ear and your physical body are being violently pushed back into your seat, but your ears are telling you that you are sitting in a quiet library. It creates a dissonance that can actually be unpleasant or make the speed feel unearned.
It's like watching a massive action movie explosion on mute. It just doesn't compute.
Ferrari understands deeply that selling $1 million supercar isn't just about 0 to 60 metrics on a spreadsheet. It's about selling an immersive, emotional experience.
So what are they actually doing for the sound?
The sound they have engineered, which the technical documents suggest, relies on amplifying and harmonizing the actual natural electromagnetic frequencies produced by the electric motors, the inverters, and the drivetrain itself is designed to provide that visceral, physical connection to the machine.
Just the real sound, just tuned.
Yes. As the motor spins faster and draws more amperage, the pitch and volume of this digital soundscape rise perfectly in tandem. It is a brilliant, highly debated blend of human psychology and acoustic engineering. I cannot wait to hear what an electric Ferrari actually sounds like in the real world. Is it a roar? Is it a futuristic whine? We'll see.
It will be fascinating.
But this deep dive into the engineering of sound leads us right into the final major section of our briefing document. Because whether we are talking about a 20,000 euro Citroën meant for daily commuting or a 500,000 euro Ferrari meant for track days, the foundational DNA of what makes a car has fundamentally changed by 2026.
The anatomy has
We've
changed.
got brains, we've got grids.
Yeah.
Reading the material section here, we've apparently got mushrooms. Let's break down the anatomy of a 2026 EV.
Let us start with the brains of the operation. If you look across the entire spectrum of vehicles we have discussed today, the single most significant architectural change across the entire 2026 industry is the ubiquitous shift to SDVs.
SDVs, software-defined vehicles.
Yes?
The data indicates that cars are now being born with heavy-duty AI processing power, integrated directly at the foundational chip level, utilizing highly advanced silicon from tech giants like Intel and NVIDIA.
The paradigm has completely flipped.
The car is no longer a mechanical object that happens to have a rudimentary computer glued into the dashboard to play the radio. The car is a highly complex computer that just happens to have wheels attached to it.
That is the precise critical distinction. The implication of an SDV architecture is that the vehicle behaves and ages much more like a high-end smartphone than a traditional piece of heavy machinery.
A giant smartphone.
Because the artificial intelligence is integrated at the foundational hardware level, the car becomes an active learner. It doesn't just passively transport you, it actively analyzes your specific personal driving style.
It's watching you.
It maps your daily commute routes, it measures how aggressively you tend to accelerate away from stoplights, and it learns your preferred braking distances.
And what does it do with all that personal data?
It uses that data to continuously optimize the entire powertrain in real time. If it knows you drive a predictable 15-kilometer route in heavy traffic every Tuesday morning, the AI will automatically precondition the battery temperature to the optimal state for low-speed efficiency, maximizing your range without you ever pushing a button.
So the car is actively getting more efficient just by watching how you drive it. And just like a smartphone, the SDV architecture means it receives continuous, deep Wi-Fi updates over the air. We touched on this with Tesla, but it's everywhere now.
It's the industry standard.
Think about what that means for ownership. You could wake up on a Tuesday morning, your car is connected to your home Wi-Fi overnight, downloaded a massive patch from the manufacturer, and suddenly, your car is fundamentally better.
The adaptive suspension algorithm is refined, so the ride is 10% smoother.
The motor controller software is tweaked to unlock 15 more horsepower. Your infotainment system has an entirely new, faster interface. The car actually improves and gains features over time, rather than just slowly degrading from the exact moment you drive it off the dealership lot.
It completely upends the century-old traditional depreciation model of the automobile. The hardware becomes a durable shell that houses constantly evolving software.
That is a wild shift.
And this constant high-speed interconnectedness is what makes the next major technological leap possible. We briefly touched on it earlier when discussing the retro Renault 5, but we absolutely must dive into the mechanics and implications of V2G, or vehicle-to-grid technology.
Yes, V2G. The reports show that models from Renault, Kia, Nissan, and many others in the 2026 class aren't just consumers of energy anymore.
They are fully bidirectional.
The hardware allows electricity to flow in both directions. They are essentially massive, highly mobile batteries. I want to understand how this physically works for the average person.
If we connect this to the bigger macroeconomic picture, the implications for our global energy infrastructure are profound.
How so?
The transition to renewable energy, solar and wind, creates a problem of intermittency. The sun doesn't always shine when we need power the most. V2G acts as the ultimate buffer. It allows the car to not only take a charge, but to push energy through a specialized inverter back into your home to power your appliances, or even sell it directly back into the public electrical grid.
Okay, let's walk through a practical scenario for the listener. Think about a typical daily cycle. You drive home from the office, you pull into your driveway, and you plug your car in at 6:00 p.m.
Peak hours.
Now, 6:00 p.m. is precisely the moment when the electrical grid is under the absolute most stress. Every single person in the city is getting home, they're turning on their electric ovens to cook dinner, they're cranking up the air conditioning or the heat, they're turning on the televisions. Demand spikes, and therefore electricity is at its absolute most expensive rate of the day.
Exactly. The grid is straining to meet demand, often relying on dirty, expensive peaker power plants to keep the lights on.
So with V2G, instead of your car pulling a highly expensive energy from the grid at 6:00 p.m. to charge, the grid effectively pulls energy from your car.
The flow reverses.
Your car acts as a power wall. It runs your house, the oven, the lights, the AC, during those expensive peak hours, completely shielding you from the high grid prices. And then, at 2 a.m., when everyone in the city is asleep, The demand drops to zero, the wind turbines out in the countryside are spinning wildly, and energy is dirt cheap. The car automatically senses the price drop and recharges itself back to 100% using the cheap overnight power.
It's brilliant arbitrage.
The sources show this can save a homeowner hundreds or even thousands of dollars a year on their electricity bill without them ever having to lift a finger or change their schedule. The car's AI handles the entire complex arbitrage process in the background.
It is a remarkable financial shift. It transforms the personal vehicle from a rapidly depreciating asset that only costs you money to fuel, maintain, and insure into an active, revenue-generating node in the global energy market that can effectively subsidize its own running costs.
That is just brilliant. You are literally getting paid to park. But none of this heavy lifting, the constant charging and discharging into the house, works without the right kind of physical battery underneath you.
The battery chemistry is critical.
Right. If the battery degrades quickly from all that cycling, the whole system falls apart. And reading through these chemical specs, I kept seeing one specific acronym pop up over and over again, particularly for the affordable cars in the 20,000 euro range.
Right.
LFP, lithium iron phosphate batteries.
The new standard.
They have officially become the new dominant standard for everyday EVs. What makes LFP so different from what we used before?
LFP chemistry is truly the unsung hero of the 20,000 euro price point and the V2G revolution. Early electric vehicles relied heavily on battery chemistries utilizing nickel and cobalt.
Right.
Those materials are incredibly energy dense, which is great for range, but they come with massive drawbacks. They are highly expensive commodities, they're ethically and geopolitically complex to mine, and chemically they're quite volatile.
Whereas
LFP batteries, on the other hand, use iron and phosphate for the cathode. These are two of the most abundant, cheap, and easily sourced materials on the planet.
which explains how Citroën and Fiat can suddenly build cars for 20,000 euros.
And it drastically lowers the floor on pricing.
But the reports stress two massive functional benefits for the driver beyond just the cheap sticker price. First, they are exceptionally safe. Because the iron phosphate bond is so incredibly strong at a molecular level, they are far less prone to thermal runaway.
Much safer.
Meaning, even if the battery is physically punctured in a severe crash or exposed to extreme heat, the risk of it catching fire is drastically lower than older chemistries.
The safety profile is undeniably superior.
And second, and this ties back to the V2G discussion, LFP batteries are incredibly durable. They can handle thousands of more charge and discharge cycles than older battery types before showing any signs of capacity loss.
They love to be cycled.
With older EVs, the advice was always, never charge past 80%. If you don't need to, you'll degrade the battery. But with LFP, you can plug it in and charge it to 100% every single day. You can use it to power your house every evening. The LFP chemistry is so robust that the battery pack will, in all likelihood, physically outlast the metal chassis of the car itself.
It provides immense peace of mind for the long-term owner. You are no longer terrified of a massive battery replacement bill at the 5-year mark.
A huge relief.
And speaking of peace of mind, the 2026 data also highlights a highly mature engineering solution to a very common, highly frustrating EV complaint: winter efficiency.
Ah, yes, the classic my range drops by 30% the moment it snows problem. Early EV owners in places like Norway or Canada know this pain deeply.
It is a real issue.
In a gas car, the engine produces so much waste heat that heating the cabin is essentially free. You just blow a fan over the hot engine. But early EVs didn't have hot engines. To warm the cabin, they used resistive heating.
The toaster method.
Basically, they put a giant electric toaster element in the dashboard, which drained the battery incredibly fast. If you want it to be warm, you sacrificed a massive chunk of your driving range.
A terrible compromise.
But looking at the 2026 models, heat pumps have become standard equipment, or at least highly affordable options, across the entire board.
The transition from resistive heating to heat pumps is a perfect example of mature engineering solving a practical, everyday problem. A heat pump acts exactly like a reversible air conditioner.
Okay, how so?
Instead of burning electricity to create heat from scratch, the system pulls ambient thermal energy from the outside air, and yes, there is still extractable heat energy in the air even when it is freezing outside, compresses it to raise the temperature, and uses that to warm the cabin.
So it's just moving heat around rather than creating it. The reports state it uses a fraction of the electricity compared to the old toaster method. It preserves your driving range in the cold, making winter road trips totally viable without needing to drive wearing a thick parka and gloves. It's brilliant.
It solves the winter problem definitively.
But the engineering evolution doesn't stop at the drivetrain or the climate control. The final point in our analysis regarding the anatomy of these new vehicles focuses on what you actually touch, feel, and smell inside the cabin. We are talking about total sustainability.
The automotive industry is under massive regulatory and consumer pressure to drastically lower the total carbon footprint of the vehicle's entire life cycle. It is no longer enough to just have zero tailpipe emissions. The production process itself must be clean.
Moving away from traditional petroleum-based plastics and heavy, water-intensive animal leathers. This is where the reports got genuinely wild and incredibly creative.
Very creative
The
materials.
data shows that the interiors of these 2026 cars are being manufactured from materials that sound like they belong in a compost bin rather than a luxury car. We're looking at dashboard plastics made from recycled fishing nets pulled from the ocean.
Reclaiming waste.
We have acoustic dampening fabrics grown from mycelium, which is literally the root structure of mushrooms.
Yeah.
And my absolute favorite, high-end vegan leathers for the seating upholstery made from industrial apple scraps left over from the juice industry.
While it sounds almost comical at first, it is actually a highly sophisticated and deeply fascinating application of circular economy principles.
Scraps.
By utilizing organic industrial waste like apple skins and reclaimed ocean plastics, the manufacturers are able to achieve a premium, highly durable, tactile feel without the massive carbon overhead associated with traditional petroleum refinement or livestock farming. The material science involved in making mushroom roots feel like soft suede is quite extraordinary.
It is amazing for the planet, absolutely. But I have to admit, keeping a straight face while realizing I'll be bombing down the highway at 130 kilometers an hour, listening to the perfectly engineered digital soundscape of a V12 engine, while comfortably sitting on a seat made entirely out of apple scraps and mushrooms. It is just a bizarrely wonderful, futuristic mental image.
It is quite the juxtaposition.
The banter at the dealership is going to be hilarious. Excuse me, what vintage is the apple leather in this Skoda? Was it a good year for the orchards?
It certainly challenges our deeply ingrained traditional notions of what automotive luxury looks and feels like, but it proves decisively that total sustainability and premium quality are no longer mutually exclusive concepts. You do not have to sacrifice comfort to be environmentally responsible.
So what does this all mean for you, the listener? Let's bring all these disparate threads back together. We have covered a massive amount of ground from our briefing documents today.
A lot of data.
If we zoom out and synthesize everything we've looked at, the solid-state breakthroughs extending range to 1,000 kilometers, the ultra-fast 800-volt charging, the highly aggressive 20,000 euro price wars bringing hydraulic suspensions and clever packaging to the masses, the 1,000 horsepower AI supercomputers on wheels, the massive LFP battery durability, and yes, the mushroom seats. The core takeaway for you is crystal clear.
The absolute core takeaway is that the era of compromise is officially over.
Exactly. 2026 is the definitive turning point. The old, deeply ingrained limitations, the range anxiety that kept you awake, the hour-long charging sessions in empty parking lots, the exorbitant luxury pricing that kept the technology out of reach for average families, have all been systematically engineered away.
The barriers are gone.
The EV is no longer an alternative vehicle. It is the primary standard. Whether you are in the market for a highly practical 20,000 euro Citroën that floats over cobblestones, a spacious Skoda that fits your whole family, or a Ferrari that literally bends the physical laws of cornering physics, the underlying technology has finally caught up to the initial promise.
The automotive industry has successfully and completely transitioned from building expensive technological novelties to building fundamentally superior, deeply integrated machines.
And now, you are thoroughly armed with the most important insights from today's rapidly shifting automotive landscape. You have the underlying data, you understand the foundational context of how these systems work, and you are perfectly prepped for any conversation, any business meeting, or any dealership visit regarding the future of transport.
You'd have the complete briefing.
You know exactly what is under the hood, both figuratively and literally, of 2026.
But before we conclude our analysis today, this deep dive raises an incredibly important macro-level question for you to ponder.
Okay, what is it?
Something that wasn't explicitly spelled out in the vehicle specs, but is the logical, inevitable endpoint of everything we have discussed today. We spent a lot of time talking about V2G technology.
Vehicle to grid.
Yes. How a relatively affordable 25,000 euro hatchback is now equipped as a mobile bidirectional battery that can power your home and seamlessly feed energy back into the public grid.
Right. The car acting as an active smart energy node that you happen to drive to the grocery store.
I want you to think about the sheer scale of that capability. If millions of these 2026 era vehicles hit the road in a single country over the next few years, we are suddenly, almost accidentally, creating a massive, highly decentralized, incredibly powerful battery network for our entire civilization.
Oh, wow.
It completely fundamentally shifts the historical balance of power. For over a century, a few massive utility companies and fossil fuel conglomerates controlled the energy grid. They dictated the price and they dictated the supply.
And now?
But in this very near future, millions of everyday drivers will collectively hold the largest reserve of stored electrical energy on the planet, parked right in their driveways. So the question you must ask is, who really controls the power grid of the future? Do we, as individual drivers and owners of these mobile power plants, collectively become the new energy barons of the 21st century?
Wow. We go to a dealership to buy a compact car to get to work, and we accidentally take over the national power grid. That is a massive structural, societal shift to chew on. I love it. Leave it to a 20,000 euro city car to spark a quiet energy revolution. Thank you so much for joining us on this journey today. Keep your eyes on the road because the future is already in the passing lane. We'll catch you on the next deep dive.